In question 6, the flower arranger sometimes uses gel balls instead of water to fill the vase. These are the gel balls, as you can see. The photograph below shows some writing seen through one of these gel balls. The writing is distorted because the gel ball refracts the light. What is meant by a refraction? So what is the definition or the meaning of a refraction? Refraction means property of a light or property of a wave to change speed or change in speed of a wave when it travels from one medium to another, or change in direction of the wave due to change in density or speed or medium. You can also mention like that. So change in direction of the wave due to change in density of the medium is known as refraction, or change in speed of the wave due to change in density of a medium, also known as refraction. The photograph below shows a beaker containing gel balls, and when water is added to a beaker, the gel balls below the water surface are no longer visible. So you can see, like for gel balls, then we add water, so gel balls are not visible. Explain how this shows that the gel ball has the same refractive index as water. Like when we fill up with water, we are not able to see the gel ball. So how it can show that the refractive index of the gel ball is same as refractive index of the water? So there is no change in direction of the light, or there is no refraction. That's why. Otherwise, what might happen if the gel balls were having a different density than water? Then there should be a refraction of the light, or light should change the direction. But because they have the similar densities, how this shows that the gel has the same refractive index as water, so there is no refraction of light from water to gel balls. Shows they have the same refractive index. Otherwise, if they were having a different refractive index or different densities, then there should be a slight refraction of the light, which make us identify that the position of the gel ball. A student decided to use a gel ball to model a formation of a rainbow by raindrops. He wants to see if the total refraction occur. What is meant by total internal reflection? The definition of a total internal reflection means when the light strike a denser to rarer boundary, it undergo reflection when angle of the incidence is more than critical angle. So that's called a total internal reflection. The student shines a narrow beam of a light at a gel ball using arrangement as shown. A laser light is there, a gel ball screen 1 and screen 2. When the light is incident on the laser beam with a gel ball at an angle of 60, angle of the incident, light from a laser illuminate the screen 2, following the path shown. So this shows, this is the path which the light is taking. We have to show that the angle X is about 40 when the refractive index of a gel, and the critical angle of a light is about 50. We want to show that. Like angle Y is 50, we want to show that. So the first one, we need the value of X, and we have the refractive index of the gel, which is 1.3, and it is moving from air. This is air, and this one is gel, which is having a refractive index of 1.33. Air is having, this one is theta 1, theta 2 we want to determine. So we'll use the formula n1 sin theta 1 equal to n2 sin theta 2. So n1 sin theta 1 equal to n2 sin theta 2. Refractive index of air is 1, angle of the incidence is 60. Refractive index of the medium is 1.33, the gel, and we don't know the angle, so we are finding that. That is actually angle X. So this will be sine 60 divided by 1.33, and then we'll take a sine inverse. Then we'll take a sine inverse to get the value for X, which is about 40.6. So X is about 40.6. Then how to work out the value for Y? Like not Y, X, we want the critical angle. Or show that the critical angle for a light striking of a gel with air is about 50. So we want to show, means if the light strike from denser to rarer boundary, it undergo the critical, if this was a critical angle, the angle of refraction will be 90. And again, we use the formula n1 sine theta 1 equals n2 sine theta 2. Now it is moving from gel to air, and the angle of the incidence n1 sine theta 1 equals n2 sine theta 2. Refractive index of a gel is 1.33. The theta 1 is a critical angle, refractive index of air is 1, and the angle of the refraction is 90. So sine C is equal to 1 divided by 1.33, and the critical angle will be sine inverse 1 divided by 1.33. This will give us the critical angle of this gel ball, which is about 49. So we want to show it is about 15, so this is 49. So the critical angle is 49. The next part they're saying the angle X has the same value as angle Y. Whether the light from a laser will observe on screen 1, because on screen 1, if there is total internal reflection, we cannot see anything on screen 1. But if there is simple refraction, as this angle is less than the critical angle, as they mentioned, angle X is equal to angle Y. Angle X was 41. When we calculated this angle, it was 41. 40.6, it is about 41. So angle Y is also 41. And we work out the critical angle. We work out the critical angle, which is 49. So this angle 41 is less than the critical angle, so light will not undergo total reflection, it will undergo a refraction. So we will see on screen 1, because on screen 1 is due to refraction. On screen 2, that is due to total internal reflection. So if there is no, if this angle is less than the critical, then it will refract and we'll see on screen 1. If this angle of the incidence is more than the critical angle, then light will undergo total internal reflection and will not see anything on screen 1, only on screen 2. So in this case, as an angle of incidence or angle Y is less than the critical angle, that's why there will be a refraction and we'll see the ray of a light on screen 1. Is it clear? Discussion? So this was exercise related to refraction of a light.